Good afternoon and/or good morning, everyone. I am Julie Fogel, Director of Marketing at MediQuant, and I'll be serving as moderator for today's webinar, Unpacking Data Types and Your Options for Storage. On behalf of MediQuant and Iron Mountain, it is my pleasure to welcome you to the second webinar in our series through the Active Archive Alliance. I have a few administrative items to share with you before I do introduce today's panel. If your screen freezes or you experience a delay, please do try refreshing your browser. Also keep in mind shutting down applications, especially email, will improve your bandwidth. We have muted all but the presenters' microphones today, but please do ask any questions that may arise during the presentation using the Q&A feature. We'll collect those for discussion during the Q&A portion of the webinar. Now it's my pleasure to introduce today's presenters who will be discussing the different data types experienced and managed in active archives, as well as your considerations for mitigating security risks. With more than 25 years of experience in data management and proficiencies in data and network security, as well as infrastructure and disaster recovery as a service, Pat Parrish serves as Solution Architects Director for Global Digital Solutions for Iron Mountain. Hello, Pat, and thank you for joining us today.
Thanks for having me. Hello, all.
Antonio Harris, MediQuant's Interface Program Lead, is an experienced project manager skilled in business process improvement and resolving complex file interface client implementations. Antonio, welcome.
Thank you. It's a pleasure to be here.
Alex Van Scoik, team lead and data engineer at MediQuant, brings significant database management and data migration experience to our panel today. Thank you for being here, Alex.
Thank you for having me.
With a Doctor of Health Administration, as well as master's and bachelor's degrees in nursing, Kel Poltz serves as MediQuant's Chief Clinical Officer. Thank you, Dr. Kel, for bringing your experience in HIT and clinical data management to today's conversation. I wanted to get right into it. What are the different types of data, and why is it important to consider those types when it comes to storage options, Kel?
That's a great question, and thank you for having me today, Julie. It's a privilege to be here today. So talking about types of data really that are dealt with in an active archive, structured data, so data such as lab data, pharmacy, audit, science details, documentation, those types of things can be in a structured format. Unstructured data such as images, TIFFs, GIFs, BMPs, JPEGs, WAV files, PDFs, those are kind of fit in that unstructured data type category. Paper, of course, which, as we know, there are still a lot of paper records out, especially whether it's in the healthcare environment or outside of the healthcare environment. There's still quite a big business around storing paper records in warehouses and that type of thing. As you know, healthcare is moving to more digital, but there are a lot of paper out, there's a lot of paper, and they're still actually documenting in some locations on paper. Microfiche and tape, both of those are storage medias really that they're a little bit antiquated in some cases, but those are types of data that actually get stored and have considerations for how they get moved into an active archive. And then, of course, audio video. So you think about sleep studies, those type of studies that require long-term storage, but they may take up a lot of space. So those are the types of data really that we're going to kind of focus on today.
Right. Alex, the examples that we're seeing here on the screen, the structured data, are pretty straightforward. Tables with identified categories, that kind of thing. What are a few things that organizations need to consider for the structured data that they're looking to manage?
Absolutely. So as you mentioned, structured data, we're looking at discrete data values, right? So think tables made up of columns and rows. You could call them records. And so that's what we're looking at when we talk about structured data. And when we consider extracting structured data in order to put it into an active archive, we talk about the accuracy of extracting raw data as well as the metadata surrounding it. So when you pull data out of a table that has columns and rows, you don't just get the individual raw value, but you have to get the metadata that surrounds it, the things that say this is a numeric field or a text field, a decimal, an accounting value. You need to extract the relationships between tables and sets of structured data that says this identifier in this table references data in another place. So when we consider extracting the data, we always think about the fact that there's a big picture. It's not just the rows and the columns and the raw values, but there's metadata that tells us what it means. And then additionally, there's a difference between just pulling that data as an extract and then what we think about when we talk about an active archive. And an active archive also has a component that ensures the data is relevant and useful for use cases in the future. So we're not just putting the data in a box and storing it forever and never looking at it, but we want to make sure that data stays relevant and useful moving forward. And so in addition to the metadata and the relationships I just described, there's a second level that we look at when we advise our customers to consider when we talk about mapping and loading into the archive. And that level is kind of the documentation and the knowledge that surrounds the way the system is currently used in its entirety. So we ask customers for things like data dictionaries, user manuals. We try and talk to the end users who are currently using the system, and we try to document as much as we can about how a customer is using the system right now, because in addition to the discrete data and the relationships, that component of documentation that says how the system was used, all of those things come together when we build a truly useful active archive that can be used for many years to come.
And Antonio, when we're looking at considerations for interfaces, what do we need to keep in mind in terms of active archives and interfaces for structured data?
Reduce some costs, support some financial backing, or make a process run quicker or smoother. So some considerations that you may want to think about is, do you have external systems or processes that require some type of updates on some type of frequency or require some type of visibility? Can a process be handled manually, or does it require that something be automated to cut down the costs or cut down time, to save time for a company, to save time for a process? Another thing that you want to consider with interfaces, because it's some sort of automation for you. So is there a need to reduce costs for the company? Is there a need to improve workflow of a process? If so, then that'd be something that would lean you toward, well, how can we handle this with some sort of interface to update these things? Something else that kind of ties to that is user access. So things to consider is, does a person need access to perform their normal work duties? Or what about the person that may be managing a department or a process? Do they need some type of access to handle a process? Also, when you're thinking about user access, some things that can happen sometimes, if not careful, is that user access can be given to a person that may not really need that visibility or need that information. So is it absolutely necessary to give this person access to complete a task? You never want to give a person access to something, and of course they don't need that access. And then that kind of rolls in under our last point there, which is support. So when you're thinking about support, we always want to ask ourselves why we need this. So, for example, what's going to happen if data is lost, if a process breaks, if a process breaks on my end or the vendor's end? who's going to monitor the process should any of the aforementioned issues occur. Is this going to be manual? Is it going to be automated? So these are some things we want to keep in mind when you're considering what type of support you may have for these things.
One thing I think to add to, Julie, on that topic is when you're talking about the interfaces, so active archiving can encompass many different things. So across industries, in healthcare, it's typically clinical data, and the interfaces relate more to what happens with patient accounting. So a lot of organizations actually can work down their AR in an active archive, and the interfaces that Antonio mentioned in that case could go to GL. They could go to agencies. He mentioned 835, 837 decision support systems. So that is a consideration too, as he mentioned what data needs to go where and what information do you need to get back, and that is an absolute useful tool to have to prevent manual processes, especially if you have a lot of AR, for example, to work down in a system from your legacy environment.
Yeah, good point, Cal. I know, with the examples and use cases around structured data, they're nice and neat and in rows typically, but Pat, is it fair to say then the unstructured data is the Wild West of sorts, so that there's quite a few variations here. Therefore, I would imagine there's quite a bit of additional areas that need to be considered when you evaluate storage options.
It's a great point, and absolutely. Unstructured data, Gartner predicts by the year 2025, we will be in the sub 500 zettabytes of stored data for unstructured content globally. Put that in perspective.
Zettabyte with a Z? Zettabyte with a Z.
Yeah, so we know what a terabyte is, and then 1,000 terabytes is a petabyte. 1,000 petabytes is an exabyte, and 1,000 exabytes is a zettabyte. I can't comprehend the amount of zeros in that formula. So safe to say, data is blowing up exponentially, and storage companies love this problem. So you talk to EMC, you talk to Hitachi, you talk to NetApp, et cetera. They love this problem because it creates opportunities to simply apply the Band-Aid approach to storing unstructured data, which is just put more storage in the customer's environment. The reality is a lot of this content is what we would call rot, which is redundant, obsolete, or trivial, and much of that is duplicate data content. So we make copies of data all the time in backup streams where you've got multiple copies of the same file, right? And if you store that without any limitations, what you have to store goes unchecked. So over time, we're really seeing, the fundamental use cases of how can I apply, good strategies around one, what is my long-term retention for any data? And is that long-term retained data sitting on the appropriate storage tier? If for instance, I'm a pharmaceutical, and by definition, I have to keep an active drug and all the file content supporting the creation of that drug as part of my record for 50 years after that drug leaves the market, you can see how that very quickly grows over time. The reality, though, in that example, a clinician or the FDA or some government regulatory body may need to look at that content once in that 50-year period. So why is that data sitting on active spinning disk? The reality is it really should not. So I kind of lumped just some scenarios and examples into everything that you're looking for considerations here. And now it really kind of goes to, what are some of the best practices in terms of those use cases? So I believe, Alex, can you spend a moment in talking about extraction? What are some of the different approaches when talking about extracting, mapping unstructured data?
Absolutely. Thanks, Pat. So when we look at extracting and indexing unstructured data, The first thing we tend to look at is the file format of these documents or images. And as it's been said multiple times, this spans every industry. Every industry has some form of unstructured data, PDF documents, images. We talk about it a lot in healthcare because we have a large number of proprietary images. So think X-rays, CAT scans, MRIs, 3D and 4D imaging, right? Those things are very proprietary. The software that you need to view those images and that unstructured data costs a lot of money and is expensive to maintain. And we try to talk to our customers to help them understand that when you archive data in those formats, you have to remember that if you're going to just archive the unstructured data in the original format, you have to keep the software and the environment in which it lives currently in order to be able to view it. You have to keep that around. You have to maintenance those servers. You have to pay for that licensing. There's a lot of factors that come into play. And the approach that we typically take is we try and talk to our customers about converting unstructured data that is proprietary into non-proprietary formats. So for example, if you had a proprietary X-ray that you got at your local doctor's office, and you took that file and you went and asked for a copy of your medical record, they're going to print you out a PDF or a paper copy of what your X-ray looked like. They're not going to hand you a proprietary disk and tell you to figure out how to read it. And so we take that approach with our active archive clients as well, because our whole point is that if you can archive these and while you extract them, you transform them into a format like a PDF, for example, or a JPEG image that can be read by all sorts of different operating systems and computers across the board, then 5, 10, 15 years from now, as you're using your active archive and making use of that data, that image will still be readable. You'll still have that data. It'll be accessible. And then the second consideration I want to mention with unstructured data, when we talk about unstructured data and extracting it, there's always a component of structured data that goes with it. If I extract 10 million unstructured data documents and I dump them into a folder on a server somewhere, and I tell you to go figure out where one financial document lives, and you look at 10 million documents and go, how am I supposed to find this, right? So when you extract unstructured data, you always have to remember that there's this concept of metadata and indexing, and tagging these. Essentially, tagging is the word we would use, these images with helpful things like it could be a patient name or an account number, or it could even be a tagging system of like a classification or a category. A way to essentially organize this unstructured data, and each of those records in that structured index would have a pointer back to the unstructured file, so that 5 years from now, 10 years from now, as you're using your active archive, it's easy to go back and find unstructured data where it actually lives, rather than having to dig through files and folders and not know what it means. So there's an element of structured data that we always have to remember that helps us make an active archive of unstructured data more useful.
And I mean, useful is the key word here, right? So when
Absolutely.
you're looking at image files, Pat, you mentioned image, data and the size of those zettabytes and all that. Image files are really big. So when you're thinking about, managing specifically image files, what do folks need to consider about that data type?
Yeah, another great question. And some of these considerations are going to start to kind of merge together. For instance, when we talk about image-based data and how the user and what kind of experience are they going to have when they're going through an extract, they're making a call up for an image. It's important to note: is that image that I'm selecting part of something that is predetermined to have a very fast RTO, right, or recovery time objective. I need that image in my PACS environment. I'm a radiologist. I need to be able to see, on demand, John Doe's oncology, his results from certain labs that can date back X amount of time. It's an active extract to image-based content that I need as a healthcare professional. Whereas in other determinations around the image data, are some of those, say, radiology studies, part of something much longer, say, the 10 years previous to John Doe's, onset with a certain cancer, and those might not be necessarily needed as part of an on-demand. So where can those images live for the kind of access and extract that I need? One is going to also then lean into the storage of the sizing of those images. For instance, with the advent now of 3D and 4D mammography studies, these file sizes can be upwards of almost a terabyte in size. One file, 1 terabyte, that equals an awful lot of storage if I'm I'm a large imaging clinic or a hospital, and I've got a very in-depth PACS system. It's knowing how I want to use those images in a meaningful way. Not all of it has to be on-prem because it's not accessed all the time. So if I'm going to send that into an archive repository, that 3 or 4D image can actually be reduced into a much smaller size. One, a thumbnail, but two, maybe a 1D or a 2D representation because it's not necessarily the active file itself. So we need to consider all these things because, again, the goal here is to think about all of the data that is under support, that needs to be readily available, and what is the subset of data that can be in other size formats that can live in an active archive, which is going to give a much better financial outlay in terms of a TCO. In terms of user access, I think this is really important. I just want to follow up by saying the user access to these images is really critical. We're going to talk a little bit later about risk and security, who is authorized, who is not, and some of those complexities. But I'll stop there. Over to you, Lori.
Well, I wanted to just follow up on something. You mentioned, shrinking down those sizes. Obviously, active files and images that are being used for diagnostics, that's one scenario. But Kel, when we're looking at long-term storage, as our clinician today, what are your thoughts around storing those images that are no longer actively being used for diagnostics, to Pat's point?
That is a great question, Julie, and actually Pat touched on this a bit when he mentioned storing something as a 2D image. So when you've got systems that are 3D, whether it's CT, MRI, you've got some oncology systems that are 4D image. Once you're out of really using those for diagnostics and they're more for historical purposes, a lot of clients will put those down to a 2D image and store them as a PDF. So to support what Pat was saying, the cost savings to do that type of activity is significant when you talk about a terabyte for one image reduced down to a PDF type image or multiple PDFs. And an active archive, having the ability to bundle those documents. So if you have a 3D image that consists of just an example 500 different images and is put into one, you get a terabyte of data. You can bundle those documents so that an end user clicks on one item and then they can quickly scroll down and look at those documents together rather than having to open and close multiple documents. It's not uncommon for us to see this in fetal strips in the active archive or in EKGs. EKGs is another good example where we can bundle documents together and shut down those proprietary systems that are very costly, as both Pat and Alex mentioned, to maintain, especially if you're getting off of that application, you want to find a way that is both feasible and it meets your retention guidelines and your requirements, your regulatory requirements for keeping the data.
Yeah. No, and Antonio, you had alluded to this earlier when you mentioned, access and user access and preventing unauthorized access. When we're sitting around talking about, data management, you have to include security. And admittedly, I hate to admit this, I totally fell for a fake email about a package delivery. I was checking my email on my phone, and it was a quick instinct to just click the link. Now, fortunately, it was a planned test by my IT team, who frankly were a little too giddy in catching me. So I will say I got to learn a whole lot about phishing. But there are quite a few numbers here just within the last, few years. There are so many new ways that cybersecurity is starting to just branch out into new situations. Ransomware we've heard of. I personally would love to hear a little more about denial of service. Some of these, like what all do we have to consider, Antonio, when we're looking at, preventing that unauthorized access to data?
Yeah, it's great that you actually mentioned that point about your experience. It brings us to a point, Julie, that 1 minute, everything that the company spent years to build and protect can be compromised and taken away in 1 minute. So while we typically focus on performing, managing, and supporting something, how we protect data or information is just as, if not more important, due to the progress in technology and a shift towards cyber technology. So there's a number of different ways that we may be attacked throughout this cyber technology with cybercrime. One of them, DOS, that you mentioned, denial of services, that's a big one that we may not be familiar with. Now, in that type of instance, an attacker will flood a system or a server or a network with different erroneous information. The goal is to exhaust the resources and the bandwidth of that system so that when legitimate requests come through, now there's no looking for the word for this. There's really no time left to be able to process those other requests. The one that's in bold at the bottom is a very important one, though, employees of an organization. The reason why that's bolded is because many times an employee may be the one that may open up some of the other attacks that are mentioned beforehand. So knowingly or unknowingly, you can click on something, you can open up something, and now you've just presented this attack to the company.
Yeah, and I know, I obviously, learned my lesson, but one of the things that it did for me is it really did increase my awareness of how easy it is to be fooled and how sophisticated some of that is. And I think, that for us, when we're talking about data management, that's very, very crucial. And again, thank you, Antonio. We can't have a conversation without it. And we're, the data encryption, when it's at rest, when it's in motion, backing up data. Pat, what about air gap data? Talk to us a little bit about that.
Yeah, it's a great point, Julie. And if you think about, for instance, Iron Mountain's really core, business was built on providing secured environments, whether they are record centers or what we call tape vaults, with the proper levels of controls, but to store with the right environmental conditions. But air gapping, if you think about it, when a backup tape, leaves a customer's environment and it goes off site to a provider that provides this service, that data is air gapped, right? It's a backup tape. It's sitting on a shelf in the right conditions, but it's not online. It's not available. The same idea really should apply to digital content. And so this notion of I am a consumer, I want to move my data to a cloud service provider because they have infrastructure as a service already purpose-built. I can have better financial synergies with my long-term archive. move data into this cloud service provider. Yet, what are their capabilities to ensure that within the realm of what they provide for services, they can air gap my data? So that can come in two basic forms. One is what we call logical network segregation, meaning that the data's come into an environment, but it is virtually network severed, meaning the data still is on disk and nothing has really happened other than a software algorithm that disconnects the customer's network topology into their storage, right? The other is utilizing processes to move data into the cloud service provider, where they then literally segregate that data off net. In other words, I'm a service provider. Can I offer you a service where I am removing the data off network, both logically and physically? In this case, it would be on backup tape, and I'm putting it into a racking system where the data is completely unavailable to be woken up. In fact, in the case of Iron Cloud Services, we provide what's called Vault Lock, which means that it requires multi-factor authentication from the customer to be able to wake that data back up, right? So we've taken some strides in around ransomware protection so that there is a gold copy that is immune from what is happening in the customer's environment. Let me go up to the first real quick, and I don't want to spend a lot of time on this. It's sensitive to the amount of time we all have, but encryption in transit and at rest is really important. Cloud service providers need to be able to provide this by default, where the encryption administrative keys are the customer's intellectual property and not the cloud service provider. And then getting into disaster recovery, what are some of those options that the providers can bring forth to the market around failover or disaster recovery testing, or I have an event in my data center where, whether it is a zero-day vulnerability, a ransomware attack, a denial of service, or I've got a real problem with my data center, what are some of the tools that those cloud service providers can offer by making the data stored in their environment usable in a production sort of way? So these are some of the considerations we always want to consider when looking towards what are the possibilities with a service provider.
For sure. Hal, I know that last one there, Hipaa, the Health Insurance Portability and Accountability Act, that's a national set of standards, right, that protect health information. But what does it mean to be HIPAA compliant? Can you talk to us a little bit about that?
Sure, Julie. Well, this is a big one, right? This is, if you've ever been a patient, you do anything with healthcare in particular, the focus is around privacy, confidentiality of the data itself. So anytime you are talking about the data types, think about not just the type as far as whether it's structured, unstructured, but does it contain personal health information in it, or PPI. So you're looking to protect not just the integrity of the data, as Pat alluded to or mentioned when he was talking about the data at rest or in transit. You're really keeping it private from anyone who shouldn't be seeing that, whether it's sitting or whether it's moving. But when you look at an active archive and you're looking at data within a system, the application, for example, you get to a different level, and that means who should be looking at the data. Are there certain types of data that need additional security to those? And HIPAA defines, the requirement for a role-based access, not only role-based. So, for example, if you are a behavioral medicine provider, there are files that behavioral medicine will look at that no other providers can look at. There are settings to set particular results with extra security on them. So maybe it requires a break the glass and a reason for that. And then, after all of the activity and you've set security around the user access, you also have to think about tracking of this, because there are audits. If anyone's, even pulling up a Google or any news app, Becker's is one that I think a lot of people look at. There are stories every day of breaches that occur. And when, data is being either or stolen, it's being accessed intentionally or unintentionally, by the wrong people. We've had maliciousness happening where, even people within a healthcare system release it out of the organization. Something as simple as viewing your friend's record is a violation of HIPAA.
Illegal. Yeah, can't do it, right?
If you are the care provider, then you have a reason to be in there. But really, even looking at someone else's record, the rule is minimal. What is the minimum amount of data that you need to look at to be able to treat a patient? And this actually goes with, the new Cures Act as well. There's going to be some additional HIPAA rules coming out here. The final ruling on those, there's some preliminaries out, some proposed rules to support the Cures Act, which eventually, it will include sending transactions using FHIR, additional APIs, and patient access to their records, which, again, when you're talking about the options for storage on data, it's important how you think about who all is going to need to access this data, because when patients start accessing their own data, your user access control measures are going to, they're going to get a lot tighter. You can't have patients accessing anyone else's data, and HIPAA is going to drive the requirements on this for privacy. And it's also, in the title, accountability. Who can a provider share, information with? It's not just the provider or a, let's say, an insurance company, right? But clearinghouses, those types of things, they all have. There's regulation around what you can and cannot share, and the tracking of who actually accessed that data, what they did when they saw it. And then a patient, obviously, because this is really around patients, they have a right to ask who has looked at my record and what exactly did they look at. So,
right.
Keeping track of those things. And when I say HIPAA compliant, your active archive needs to be to support that. Those are, again, federal regulations. You need to be able to support the requirements for those.
For sure. And you mentioned a couple modernizing techniques, and that's a good segue into the next topic around reducing those risks. So, how you're sharing information, like the Cures Act and the interoperability standards that are going into place. But in terms of software solutions, I'm thinking about, folks that tend to leave older systems online just to continue to provide user access to the information that's stored within them. Now, I know I get, alerts that I have to update software going to, for my phone, so it's like I need to make sure I have this update. I'm not getting those anymore for those systems. That I would assume creates a significant problem.
It absolutely does. And again, this not just the support part, but you think about when you get something that's outdated. So part of a software release, for example, not only is it enhancements to something that's going on, but the vendors are constantly working against those folks out there that are looking for ways to get in and compromise your system. So there are always patches going in there, as one hacker creates something to get in, that the vendors are creating things to keep them out. And so they're constantly updating support on software, keeping hardware current, because, if you've got hardware that could be faulty, like old servers, that type of thing, it would, if you lose a server, for example, and you don't have a good, backup process or disaster recovery process that Pat was talking to earlier, you lose a lot of important data, right? And the same with the physical support. I mean, if you leaving laptops around and, anything that's in the laptop, keeping it encrypted, tracking that kind of stuff as well. So anytime you do like an inventory of your software and your hardware, think about not just the hardware that's sitting on a desktop, but also those things that move, your mobile devices, laptops. All of these things need to be, these are all modernization strategies and things that you have to think about when you're talking about your data storage is where you're storing it, how you're supporting it, how do you stay in support, because all of those things become risk areas and should be identified as risk areas.
Yeah, for sure. And I know when we're looking at, the consolidation idea here, the fewer solutions you've got out there, the fewer points they've got for access, right? That I think, Antonio, when you were talking about some of the security stuff, if they've got less ways in, that's a smart move. What other advantages are there to streamlining that tech stack, Antonio?
Yeah, I'm glad you mentioned that. In essence, it's a one-stop shop place for your data from different platforms or different areas all in one place. So another great thing about consolidating is that you're able to have one location where you can view data or information across different systems. Think about the amount of time you spend just logging into different systems or trying to go and get different information. You don't have to do that when you consolidate it. You don't have to move across different folder paths for access. And also, when you consolidate something, it's quicker to troubleshoot a problem, right? If they're all on the same platform or the same system, they're consolidated. If there is some type of troubleshooting that needs to be done, well, you already know how to handle it by working with this one system. It also cuts down on training. You don't have to train individuals on multiple different things, cuts down on work process, time spent. You don't have to go across different places. And also time spent on support is drastically reduced when the different information shares the same platform.
Yeah. And when you're looking at converting the format conversions, and this is actually more probably Alex, how does that help reduce risk when you're converting those formats?
Sure. Well, I mean, as you said, it's all consolidation here is the name of the game, right? And so what I mentioned before, when you have these formats that are proprietary and they require legacy environments, we often see people trying to keep these legacy environments. Like you might keep a Windows 2003 server, which is way past end of life, but you may keep it around because it's got an image viewer on it that you need to look at these special images from an old system. And just by having that server online, any IT department will tell you that you're exposing yourself to vulnerabilities and risks because it doesn't receive the same updates. It's out of support. And so as we recommended moving our customers to converting these images and these unstructured data elements as they extract into more universal formats, that allows us to then have an active archive that is up to date and available for use for many years down the road without having to maintain old servers, old applications, stuff that's reached end of life. So really just building on the other points here is it becomes this one-stop shop and it's easier to maintain. It all stays in one location and it lowers the risk and the vulnerability for the whole company.
Yeah, I mean, and Pat, looking at the statistics here, 30% of IT budgets allocated in 2018, and the percentages that go to the software, infrastructure, and platform as service, and the amount of money that is anticipated at 1.3 trillion by 2022. The cloud is where it's at. So, what other advantages does that offer organizations in terms of managing its risk?
Fantastic question. It absolutely does, by virtue of a very simple formula. IT professionals that are tasked with backing up their data follow a very routine industry premise called 3-2-1. 3-2-1 is I need to ensure that I have 3 separate copies of the same data. I minimally need to have it on 2 different formats. So we'll use disk and tape as the examples. And minimally 1 copy should always be off-site, right? That's just good industry practice. That off-site copy to a cloud service provider helps check that box, right? Because the risk of not having data away from my primary location is immediate risk, right? That could either be a disaster locally. It could be all the threat vectors that we know. Let's enter into now the notion of what's called 3-2-1-1, which is the same formula. The second one at the end now is an additional copy that is air-gapped, right? So cloud service providers now are getting into the market of being able to ensure that it's not when ransomware or that zero-day vulnerability will occur, it's when, right? So companies that adopt that mindset still should spend all the necessary tools on prevention with the right kind of software and hardware tools that can be deployed, but they should always have in the back of their mind that someday something's going to happen. How can I recover, right? So a cloud service provider for sure helps that. It's also important to make sure you're aware of what cloud service provider you're using for any of these services. Is it public, is it private, or is it hybrid? And I say that because the big public utility hyperscalers, you're very familiar with the top two, they live in what's called the public utility zone, meaning that the access to their environment, while it can be locked down and can be very secure, places the burden on the customer to configure their environment with the kinds of security protocols that make most sense to them. The big hyperscalers don't do that by default to their customers, whereas in the private and hybrid cloud storage providers, this is precisely what we do, right? We go through the painful task of whitelisting IP addresses, ensuring that data in transit and at rest is encrypted, and that, you know, the access to that data is only for that customer with the right kind of monitoring tools where, you know, we're actively trying to penetrate our own ironclad network minute by minute with, you know, great results in showing that it's a hardened network topology and you can't get into the environment unless you have credentialed access. So you want to be mindful of that and try and make sure that you're going through those checkbox things. And I will say one final comment that, you know, InfoSec today with most enterprise customers have a very thoughtful checklist on ensuring that their security into a cloud provider meets certain minimal criteria. And in most cases, it's a very expanded list. And you know, again, working with a cloud service provider that is willing to help you know, check those boxes should be very important and top of mind to any consumer of a cloud service.
For sure. And I know we're getting close to the end of our webinar. I just wanted to give a quick summary here. Obviously, we've talked about your data types and your options for each of those. You know, planning and evaluating all, like to Pat's point, all of your security and evaluating your risks, looking at the cost considerations. I did want to just chat a little bit before we go to the Q&A, because I did see a couple come in. You know, we know the cost. We saw that note earlier about a data breach being like $3.86 million. What about a cost savings to avoiding such things? And I think maybe that falls under the data stewardship sort of plan here at the bottom of this slide. Kel, could you talk a little bit about the benefits of, you know, having a strategic plan for your data and really kind of being a good steward of your data and how there is maybe a cost savings for that?
Yeah, absolutely, Julie. So the stewardship is really what you mentioned. It's really taking care of of your data, right? So part of your plan, anytime you're going to, for example, an EMR, should start right there and look at the life cycle, the system life cycle of the data, the life cycle of not just the data itself, but the hardware it's on. And part of your plan, when you start a feasibility study to do a new implementation or replace something, needs to include everything from start to finish. And finishing, when you really look at the life cycle of these things, is decommissioning the legacy systems. That's the goal, so that if you're, you know, putting in a new HIS system, the reason you're doing it is because typically you're getting rid of multiple applications and you're consolidating into one application that will handle the majority of that activity that you need. Again, reducing that footprint. So part of that strategic plan needs to involve the archiving side of it. What are you going to do with the data in those systems? Are you going to do some sort of conversion? Are you going to put in an active archive? How often do you need it? So that comes down to your data rationalization exercise, which is part of the overall plan and should be part of the feasibility study when you start looking at everything that you're going to need for an enterprise project. It becomes more of an enterprise project not an after the fact discussion, and it really needs moved up early in the discussion. But part of data rationalization is, one, getting an inventory of what you have. You start looking at what are the retention guidelines, when are the support end dates, how does the hardware look, is it stable, why would we keep this system up, is it being replaced by the new HIS system and we need to do something with the data, how often do we need to access it after? And really start rationalizing, is it old data or data that you want to hang on to, but it's not related to patient care? Maybe you could put it in a data warehouse. Are you going to use it for secondary purposes? Maybe it's out of the retention period, part of it is, and you want to move it to do research on it. So there are a lot of different options for what you can do with that data. Some of those options are obviously driven by what your retention guidelines are. What kind of data are you talking about? How long do you need to store it? And to something, Pat mentioned earlier, if it's something like oncology data, you want to keep it close because there are max doses on medications for those patients. If it is deceased patient data, you don't need to access that on a regular basis, right? So you move it off to a different tier of storage. But if you want to do research on data, you can de-identify the data off those systems, and you can set up a server just to do research on. So there are many, many considerations when you start rationalizing what you're going to do with the data. And again, the life cycle of the data is very dependent on retention guidelines and requirements. So that also touches on the use cases. So if you think about the cost of things, two different ways to look at cost. One is the cost savings that you get by reducing the footprint. Antonio mentioned earlier getting things, and Alex, onto one database. So if you've got your HIS system and you have an active archive, you put it all in the cloud, you go to the Iron Cloud, for example, that reduced your footprint significantly, which also reduces your risk areas, and costs that you can't account for immediately might be those risk factors, those things where someone, ransomware gets in, right? So you reduce the risk points or the points of entry, and you take all of that into consideration when you're putting together your entire plan of how you're through the life cycle of the data and what your overall strategic enterprise plan is. There are a lot of things to consider. So a stewardship type engagement really helps clients understand what that is. What are the things we have to consider? How do we put together a plan and prioritize the applications that need archived, or maybe they just need to get rid of the data. Maybe they don't need it anymore. Maybe it's no longer required for the retention guidelines, and they don't want to keep it. They want to purge that data out so it's not discoverable. So there are a lot of questions and a lot of scenarios to go through. So it's kind of important to think about it again early in the process, when they start looking at and doing feasibility studies on replacing or doing something, new applications within the organization.
And I know we did have a couple questions. We have about 5 minutes left or so. This is the Q&A portion, folks. So if you haven't already done so, please do send a question in. We have been monitoring these, as I mentioned earlier, and I have a couple that came in. And this one, I remember this one we touched on a little bit when we started talking about use cases around the interfaces, Antonio. So I'm going to ask you to take this one. You mentioned, and I think Kel mentioned as well, working with an active archive, when and where would you need an interface? And I think we talked a little bit about the fact that you may want to deal with your accounts receivables. So that interface allows you to do that with your active archive. Is that the gist of what I got out of that earlier? I think they were looking for some clarification.
That's correct, and I'll try to touch on this very briefly. Long story short, you're definitely going to need an interface. It would make sense if you have a lot of open AR still out there in your business that you need work down, or you have some type of agencies that may be collecting on things, or your finance team needs to get visibility with handling the general ledger. You would even need one if, of course, there's some visibility that's needed on how the accounts and how the AR is being worked. In all those scenarios, an interface would definitely make sense because it allows for a system that you may be using externally to be up to date, and it also allows for you to internally continue to work down AR if you have a lot of it.
Great. And then this one was about the cloud. Pat, you mentioned, obviously there's a bunch of different options. What are the risks to using a public cloud? And if you want to touch on a few of those, Pat, that'd be great.
Sure. And I think, the one notably that comes to mind is the configuration of a storage container. Like I mentioned, the large hyperscalers give you a menu of options, but the onus of the security and the protection of your data is squarely on the shoulders of the consumer. Whereas, for instance, with Iron Cloud Services, support, onboarding, implementation, the configuration of the network topology into the customer's environment is done with an Iron Mountain implementation professional. So those are some of the things to look for, but related as well, you want to look for some synergies with how the hyperscalers provide their services from a cost perspective. Some of you out there might have experience in using AWS, say EC2 for web services. The storage content to that is at a defined storage cost, but as soon as you start accessing and egressing data from that environment, there are additional charges based upon the volume that you're extracting, right? So, look for some of those providers that provide a simple storage cost that includes all the operational fees. And again, when we talk about hybrid private versus public, it really is this connotation around how the network itself is locked and engaged to really only support the customer, where outside entities, first of all, if they try and access that environment because we have active monitoring systems, we can even see that being an attempted breach of our network, and we can suspend all that activity. So just some of those considerations to look for.
For sure. And unfortunately, we are at time. And I just wanted to thank all of our speakers today from MediQuant and from Iron Mountain, as well as to the participants for asking such insightful questions. And you were paying attention the whole time. So there were some really good throwbacks to some earlier conversations. To learn more about active archiving, please do visit the Active Archive Alliance at activearchive.com. You'll find research on archiving trends and more information about best practices. For more information about data management solutions and ways to better manage your organization's data throughout its life cycle, visit the Iron Mountain and MediQuant websites. Before we close, I do invite you to join us for the next in our webinar series, which will be slated for July, and maybe we'll get to that question that may inspire an entire topic, which the question was, how do you best plan for your active archive? Until then, on behalf of MediQuant, Iron Mountain, and the Active Archive Alliance, we appreciate you taking your time today to join us. Thank you, and enjoy the rest of your day.